So welcome. Anyway, this is going to be quite a technical talk about all the guts of event delivery in LibreOfficeKit and also Collabora Online as well. And hopefully it will help us understand what happens in what order. And having fouled it all up, I will have plenty of chance for question or discussion or thoughts from other people. And so, yeah, I look forward to that piece. But do jump in with any questions you have at all, or there's a wonderful chat thing in Jitsi. So, just type a message on the side, type here, and hopefully I can respond to that interactively as we go along. So, whatever it happens to be. So first, it seems obvious, but I don't know that it is obvious. So let's look at it just quickly and explain what the terms mean, I guess. So asynchronous versus synchronous. So a synchronous operation is essentially just going to block you until it completes. And so if we look historically, computer APIs were very typically synchronous because things happened sufficiently quickly that it didn't make any difference. So, a synchronous operation is something like this read call, and that's sort of do it now while I wait for the answer. So if you look at the C system calls that we have, you'll see that actually even the socket calls that we use for talking to the internet and getting data off web sockets and TCP sockets still use these relatively old APIs like this. And so, yeah. So one of the problems, of course, with that is that if, for example, you're reading from a internet connection, it's quite probable that it might never return, or it might take a very long time to return. And so the consequence of that is if you do a synchronous operation, you get to wait. And that's really not very cool. Particularly if someone else might want to be doing something at the same time in that thread. So asynchronous operations then tend to be non-blocking, and you do it and it returns immediately. So you can get on with doing whatever it was you were doing. And at some later point, the information comes back. So here we have an async read function. I'm making one up here. And this then we pass something into it, some kind of closure, some callback, and that's going to get called when the information's there. So, of course, who calls you when the information is there is not very obvious in this case. Your program carries on running, but eventually you're going to need to do something that will then see there's some information has come in and then call you back. And so when that happens and how it happens is obviously not implicit in the read async function, and it's really explicit in the read function, isn't it? When the function returns, it'll give you the data. And well, it may tell you there's an error, and it'll put the data into the data pointer, and presumably not more than buffer size. So that's the difference. Now, of course, there are variations on this. So there are other things you can do, and in fact, the read call up there is also used for non-blocking I/O. And so if you set your socket, and I should have probably so this is a member function. But if you set your socket to have an O non-block on it option, then what you'll discover is that if there's no data to read, it'll just return an error, and that error will be E again, as in try again in a bit, And sometimes you see this in strace logs of things. If you're seeing an E again error, it just means you have a non-blocking socket, and you should come back later. So the question then is, how do you come back later, and how do you find out when to come back? And we'll talk about that in a bit. There's essentially a polling system call where you can ask the operating system, hey, what of these sockets has something new that I should go and do on them? Anyway, so asynchronicity is all great and all that, but you end up with a number of problems. So one of the problems here is a producer-consumer mismatch. So you can imagine someone doing 1 million write async calls very, very, very quickly. And there are lots of variations of this, people streaming too much logging data or some such. And the problem with this is that unless you can consume your hello worlds quicker than you can send them, they have to go somewhere. And so, we build up lots of hello worlds somewhere, and we have to queue them up. And TCP has this great benefit, of course, that it's doing this flow control part. And the flow control, of course, tries to balance these two producer-consumer things, so that the download server, when you're downloading something, doesn't try and push data to you faster than you can read it. That's kind of important. Obviously, if it's a very large server with a gigabit connection and you're on a modem, it helps if there isn't sort of a gigabit of file coming at you and you can only get 56 kilobits or whatever. So there's lots of protocols to try and manage flow that we sit on top of and we tend to ignore. They seem to work reasonably well. But either way, how this is solved, either with a complicated protocol to negotiate flow right like that, or by queuing and then protocol knowledge. So for example, when we type something, we get an invalidation, and the invalidation says, hey, this bit of the document changed. And the good news is there's a limit to the number of bits of document that can change. So as long as we know that it's a document, we can squash these invalidations together and go, you've already invalidated that. We know it's invalid. We can just send one bigger message. So you can pack a ever larger message saying this is invalidated, but it won't grow without bound. There are other kinds of changes, like state changes, that we can squash together. So for example, if we get dozens of the same state change, so like it's a modified state and it's still modified, and now we've modified them, we can crush those all into one state modification. Perhaps if it's a mouse move, we could hypothesize that we don't need 100,000 points here. We could perhaps interpolate them or send some more clever command that says the mouse moved from here to here. So there are various ways with knowledge that you can squash those things. At some point, they all stop working, and you just have to close the connection. And so, yeah, there you go. Life is bad. Or consume infinite memory. I mean, one or the other. And it's best generally not to consume infinite memory. So asynchronous things have some differences around debuggability. So, of course, if you do things synchronously, there is a stack frame for everything you're waiting on. So every read call that you're blocking on has a thread, and that has the stack frame, and you can see where everything came from. And if you run a backtrace on all of your processes, you can see what they're all waiting for and where they all are. Conversely, in an async program, your stack trace typically gives you an empty loop. We're just waiting for something to happen. You're always in the poll system call. And so the question then is, how do you work out, what the state is and how to debug that? And so we have this rather nice tool where you can send a user2 signal to a col.la or a FallKit process, and it will start to dump its internal state out to the console. So you can see, what's going on, who's waiting for what, and what the state of the buffers are. Is there a whole load of data backed up somewhere waiting to be sent to someone? Are the queues with lots of events in, and so on and so on? And what you'll discover is that computers are extremely quick. Typically, there's nothing queued anywhere, like it's all been sent, whereas in flight. But at least in theory, you can see where things are backed up. So the question is, given that you can't see and it's harder to debug, why would we do things asynchronously instead of synchronously? Because each of these are an option. The problem with the synchronous approach, and that's essentially how we started Collabora Online way back in the day, because it was quick and easy, was that it gets rapidly not very quick and easy. So if you have, for example, a TCP connection that's going out and also coming in, we need to be able to read and write on that at the same time. There is no read-write syscall that will either read or write and give you an answer as and when there's data. So you then have to have one thread doing reading and one thread doing writing, and then often another thread to actually do stuff with the information. And so you end up with these very large number of threads. At least 2 and perhaps 3 per socket, trying to work out what to do with it. And it turns out you can do that. It just becomes very, very hard to debug and to read, and there is cost to that at the operating system level as well. So generally, getting rid of all of our locks, getting rid of most of the threading in online has been extremely helpful. Having a very simple thread model makes it possible to reason. And reasoning is hard, even in the synchronous mode with lots of threads. You still have ordering problems. So one of the big problems of the asynchronous events is essentially that you need to see what happened in front of what else happened. What order did things happen in becomes very, very important. And you know, in any complex system, this is true, but it's particularly so for what we're doing here. So LibreOfficeKit. So how does this work? So LibreOffice as an application has what I call nastily complicated threading. There's a lot to be said about it. I won't go into any real detail, but you know, if you're on Windows, there are threads. In order to use the Windows API from different threads, there are some things that have to be done on one thread or another thread, and so there's a lot of posting of things here and there, which is kind of a disaster. But luckily, we have a headless backend, this SVP inst, that has a simpler yield function or a poll function that we just wait for things to happen. And and we have essentially one big lock around most of the code. Now, there are some other areas where we don't do that, and we have actually some success in taking small pieces of code and doing manageable targeted threading, where it's in a domain that's small enough and simple enough that we can actually think about it. And we can do silly things like code locking, where you just lock around any of this code and that locks its data. And you know, and you can look at this and start to think that it might actually be thread safe, which is useful. And some of those are like image scaling and zip compression, decompression. We have some awesome stuff around XML parsing to make XML effectively a free format, as long as we consume more slowly. And the formula engine, and probably there's a few others there. I think Config Manager has some threading, but broadly we have one plus not much threading in the core. And to do that, we have one big lock that goes around it called the Solar mutex. And as and when we poll, we release that. So there's a thing called the Solar mutex releaser that takes this recursive lock and releases it. And so pretty much everything that we do uses this one main loop. And that main loop has at the center of it a yield function. And the yield, you get back to when you've finished doing things. And there's various primitives there, but the key things, there's posted user events. There's, which I forgot on my slide, and there's idle handlers and there's timers. And so the idea is, if you want to do something when not much else is going on, you can put an idle handler in, and hopefully everything important has happened by then, and you can sort of prioritize these. And if it's really unimportant, you can put it in a timer. Back in the day, all of our idle functions were in timers. So you picked a number of milliseconds that you thought was late enough that it would be okay for a low priority thing to happen, and you would hard code that number into your timer. And this was not great. It was, you can imagine this going really wrong, that your low priority thing has just happened to, become high priority because the time has changed, or time has advanced, as it so often does. So that was a bit of a pain. So we reworked that, and we have some reasonably well prioritized idle handlers and timers as well for various things. So that's how the LibreOffice core goes together. So what is a main loop? Well, the main loop essentially exists just to suck events from the operating system or from the user and manage all of the things that are going on. We talked about the scheduler there, so these idle handlers, these timeouts. And so you're using a Linux machine, it is sitting there and it's polling on the X server socket. So there is a file descriptor that is used to talk to the X server, or your Wayland, I guess, in these modern times. And it's just running a system call on that called poll. And all poll does is it just waits. It doesn't actually poll, which is one of these ironies of naming. The Windows call it for wait for multiple objects, I think, which is perhaps a more helpful name. And so your computer should be asleep most of the time. Mine's almost certainly asleep now, having got bored of me talking. And it sits there waiting for more work. And those functions there import yields in LibreOfficeKit and things coming out of the scheduler there in the core. And even when a process is super busy, we have 10 users concurrently typing, there's still quite a lot of time spent in that poll call. So pretty much any delta to 100% CPU usage, and perhaps even more than that because we thread the slow bits, it's just sitting there not doing anything, waiting for something to happen. So there's some problems here. The LibreOffice has actually no good async IO abstraction and or any APIs that I'm aware of to do anything useful with IO at all. So LibreOffice essentially mandates using synchronous threaded IO. One of the problems, incidentally, of synchronous threaded IO is that it seems so simple to call some library that calls something else that does something that then gets you some information. But the problem with this is that were you wanting to cancel that from another thread or stop what's going on, it's often not very easy to work out how you dig down through those layers to stop the thing in its tracks. How can you get a cancellation handle to make that happen? But even so, we can do that. But LibreOffice has that model, and col is 100% asynchronous. Well, nearly. There are some things like DNS lookup that is pretty fundamentally synchronous at the operating system level. And so we put those in a thread and provide an asynchronous API increasingly to help that happen. So some years ago, we used this thing called Unipoll, which was essentially to try and graunch together the polling thread of the LibreOfficeKit core and Collabora Online. And that's a pretty nice code path. Essentially, it replaces this poll call, or I think actually headless doesn't have an X socket to listen, so it just sits there in a condition variable waiting, like a sleep, effectively. We replace this with our poll callback like this. So we put a closure in, and we get called when there's nothing else to do, essentially. And we pass this timeout microseconds in at the bottom. And so finally, when the LibreOfficeKit has finished doing something, we get to do something. So how does that look? Well, the first two pieces on this side here are actually in the same process. So why I say yield poll here, it's not really yielding, it's going to the col.la piece. But these other pieces are really yielding. And I've probably repeated myself a lot, but I really just want to get people used to this idea that most of the time, process is just waiting for something else to happen. So what's going on here? Well, the LibreOfficeKit is just processing some work. Maybe we've just typed in a document, and it's got some idle relayout of the page to do with some complex layout algorithm. And it's going to generate some events, and we just emit those directly into col.la. And this is slightly misleading, as we'll see in my event queuing slide later. But these events come out. So maybe the document size changed. We need to tell people about that. So we send those down a socket, and this is a hard process barrier here to another process, the WSD document broker. And this then sends them onto the browser, and the browser does something. So maybe the status bar changed. There's now more pages, and we need to update the status bar. So it goes away and does that. So that's one use case. But eventually, LibreOfficeKit finishes doing whatever it is doing, and it calls yield or poll, the unipoll poll. And that then looks at all of the incoming sockets and sees, is there anything coming in from the document broker? Is there any work that we need to be doing? I should put an arrow of stuff coming in, I guess. It then sort of pushes non-rendering events. So things like keystrokes and other things all get done first, and those are pushed into the core. And then we ask the core to render some tiles, and we then send some of these results out there. Of course, all the time, as we push, say, keystroke events, more events are coming out, and they're going through down this cascade to the browser. But essentially, that's what happens. Now, of course, the ordering of these things is really quite important. So there's several different ways that different behavior can happen from the same events. So for example, as the document broker pushes things into the forkit, it could be busy. It could be busy doing something in the LibreOfficeKit, processing things, and it may not, read its events from the socket before it gets to sending some event out. So then ultimately, events can be coming back whilst incoming events haven't yet been processed. So there's a little queue here in the col.la, and that's got a whole load of these events. Of course, typically we retain the order of those things. We try not to shuffle event order in this queue because, well, there's some madness there. Now we do some collapsing of things. So duplicate invalidations I talked about, duplicate tile renderings, we squash out. And we also try and collapse duplicate editing. So if you've got 10 individual keystrokes, we'll squash them into one big text input, just to reduce strain on the core, and also really so that as and when things get more complex, we can compact events down, and in a high latency environment, we can then save work, which is kind of useful in the producer-consumer model. If you can do less work when you get more events, life is quite good. So yeah, so then we render, and having compacted our rendering, we send all of that out. But yeah, you can see that things can happen in different orders, that things can trickle through because events go really in multiple directions from the browser. through to the kit. And my diagram is not as good as it could be. Never mind. So I thought I would just sort of round up with having some look at some of the cues that we have in between to try and get everything in the right order and mediate what's going on, hopefully in a helpful way. So the first one, sort of closest to LibreOfficeKit, is right inside the core, and everybody uses this whether they know it or not if they're using the LibreOfficeKit API. So we queue the core events before sending them. Now, why is that? Well, one of the problems is that it's nice if all of the events come out in the same thread. So whilst we don't really parallelize much of LibreOffice, it is possible to use multiple threads, and people go and do that for whatever reason. And so it's nice then to be able to push all of these events into a queue, have that thread safe, and then suck them out and push them in a more structured way. It's also really nice to get rid of duplicates. So the core really, if it can, every time you move the cursor, it will say, ooh, there's a new ruler, at this paragraph location, and it's exactly the same as the last one. And here is what it looks like. And so you can get, spews of events that are just completely pointless. And so one of its functions here is to try and deduplicate those and essentially throw them away. Of course, it would be really nice if the core didn't generate pointless events that were duplicate and redundant, but we live in the real world. And so it's nice to have the queue to get rid of that. So that's pretty nice. And ultimately, after all of these things have happened, we post a user event, which means that as and when we get to the beginning of the next poll, we can process all of those things and send them all in a batch to the kit client, I guess. So that's the first side. Now, in the same process, on the other side of that, the kit has a queue of its own. And this queue then gets, of course, incoming callbacks from this callback flush handler in the LibreOfficeKit core. And that queues all sorts of incoming events as well from the document broker. So it's got two sides. It's got the LibreOfficeKit core and the document broker telling it what to do on the other side. And when we do a poll call, which we've hooked with this kit socket poll out of the LibreOfficeKit core, we first send those callbacks on. Obviously, all those events that were queued up, it's good for us to get them out and send them to the other side. And then we process the incoming events, obviously, shuffle those around, try and get them in a sensible order. And incoming events get queued with this queue message thing that, just puts them in a simple queue. So there's some similar work going on there in terms of sort of reducing duplication. But this is where, for example, tiles are rendered and we deduplicate things there. So we normalize people with similar views and we make sure that the tiles are rendered sensibly. What else? So then the document broker has a queue, of course, that processes incoming data from the kit. Actually, we don't tend to queue that. We just process it as it comes in. There's one fat socket coming in from the kit that handles all of our clients, all of our internet connections for browsers, I guess. And so we process all of the data coming in there really as quickly as we can. And then for outgoing data where we're actually talking to someone over the internet, obviously these people could do antisocial things like turning their computer off or, not listening and not reading anything off the socket. So we try and write, but essentially once the buffers get large on that, we start queuing data and hopefully sharing that data between multiple users who are potentially listening. And then when there's space, we get this write queued messages call that says, hey, I could do with a bit more data. Can you write some to me? And so we then send a whole load more messages to fill up that socket. So that's how that bit works. And then on the JavaScript side, and this is where I ran out of steam in my my talk preparation earlier, we also have a queue. So one of the problems with the browser is that touching the DOM is extremely expensive. So you would think that what you need to do in the JavaScript is have something as simple as possible. You have a WebSocket and you read messages off it, and then you just do what they say, right? So like if there's a change to the cursor position, you should just move the cursor, tweak the CSS, and you're done. And that would be a good idea, except that almost certainly immediately after the cursor move, there's also a new tile with information in it and a new a word count, status update, and all of these need to touch the DOM. And the problem is that every time you touch the DOM, it forces a complete, re-render, style, whatever. And until you've done that, you don't get your next WebSocket message, which is something we discovered to our cost too late. Really silly. But anyway, if instead you read all of your messages from the WebSocket and you pile them into a queue, and you wait, say, 1 millisecond, although now we have a variable time there, depending on how much work we think, or how much more we think we're going to get, then actually you get a massive performance improvement from a sleep. So that's all rather nice. And then you can have enough information to touch your DOM all at once and prepare effectively a new scene that you can see. So that's quite surprising. So that's the slurping queue. We essentially slurp lots of data, and then we, well, maybe we swallow it if it's not too hot later. I think col.la recently added something there that changes the slurp delay. So if we predict there's going to be a screen full of tiles, we'll wait until we've got a screen full of tiles to do it, which essentially improves first start and large page change usability. You get less tearing. So that's good. And then there's this delayed messages queue as well. So when we first start our WebSocket, it can be very helpful if we have a certain number of events already there before we start processing them. And similarly, the browser can be in quite a confused state when it starts. For various reasons, the browser people have decided it would be infinitely wise to not have a defined order in which your JavaScript is initialized. So, it could be all there, or it could not be all there, or only half of it could be there, and it could be running already. And we see, we've traditionally seen horrifying race problems with this, where you've initialized one JavaScript module but not another one, and now you need to process a WebSocket message that assumes it's there because it's almost always there, and it is there. And this has caused problems with testing and robustness and God knows what in the past. And so now we effectively delay all of the incoming WebSocket messages. We want to get the WebSocket up as early as we can, because that helps the document load. It helps give some idea of screen size and start rendering tiles and things like this. But yeah, we don't really want to be processing the messages until we're 100% sure that all of our JavaScript's loaded, our window is ready, and we're ready to go. So we delay those. And sometimes if you dump your protocol dump out to the console, you'll see that a number of those have like a prefix on the message going, yeah, but we delayed this. We didn't emit this message until it was, until we got to the certain point, and then allowed that event processing to happen. So all those happen in order that they come in. Obviously, there's no reordering at all there. I think he lies. Actually, the tile messages we now try and process out of order to get them more quickly there. So we process invalidations much earlier, so we can try and predict how many tiles we're going to get, even while we're queuing information and waiting for them. So there's some early processing of that that's got recently added in the last month. Almost certainly we'll be doing web worker decompression of tiles, because that turns out to be a win from Chris's profiling. So that's probably coming, hopefully, in this red window. But broadly, all of the messages happen in a sensible order. All of the interesting ones are processed and consumed in the order that we got them from the call. And that, I think, is where I run out of slides. And your name has been doing a great amount of work. So I think that's where I'm at. Probably if there are questions, we should go back to something like that to have some idea of what's going on. But thank you for your patience. You're very good. If you're not careful, you will be polled individually to see if you have questions or comments to add. So if you don't have them, write them down on the side. And thank you for your time. So, Mevin, over to you. You happen to be at the top of my list again. How do you manage that? I don't know. That's great. Do you have any questions or thoughts?
Well, no, so far.
No thoughts so far. Pedro has already bunked about out of questions. No, just before I wrote your name down. Look at that. So, Andrash, no questions. Ash, thoughts, comments? I'm sure you have something intelligent to say while I'm writing people's names down.
Yeah, I don't know if it's very intelligent or not, but I think
I'm sure it is. Go for it.
In passing that where we can, we look at the buffers that we have for the various events, and we try to deduplicate. Basically, if we know that a subsequent event overrides the previous one, we don't need to process 2 of them, so we collapse them and we deduplicate wherever we can, and we do this variously at the different, stages and processes and queues, which help, with latency and overheads.
Yep. Yeah, of course, it helps with the amount of work we have to do, and also the producer-consumer problem that we have there as just a general problem, I guess. So I'm now racing through these things. Rashesh, Vivek, Timur, Attila. Who am I going to pick on? So Byram, have you said no questions yet? That's the question. Aha, there he is. Aaron, any thoughts, comments, queries? Timur, you have comments. Fantastic. Go for it.
Well, it's not really a comment. It's more a question.
Go for it.
So,
all is good.
I see that there is an emphasis on a performance improvement, and it's happening continually, all the time, like in some specific areas, issues, whatever, general. But looking long term, how would you say, maybe looking at this exact image that you are now showing, so long term, do you see some more performance improvements? Like, would it be in LibreOfficeKit or in somewhere else, or some areas, or some rework, or what? Just talking about long ideas.
Yeah, absolutely. So, like, looking at this picture here, in terms of performance, we're talking probably microseconds to get between the col.WSD document breaker piece and the LibreOfficeKit core on the 4-kit kit piece. So it's very quick to do that. We have a Unix domain socket. There's no protocol overhead. It's really ultra fast, and there's very little buffering or blocking on buffers because we can use lots of internal memory. So, one of the thoughts we had was to move more of the document broker logic into the col4kit process. That might work, but there are some quite nice benefits here of keeping a session around, and there are some things that we can do that we could do in another thread, I guess, inside LibreOfficeKit. Yeah, not clear to me. So one of the things we could do is we could pass Unix, we could pass sockets over the Unix domain socket we have. So we could take the TCP sockets, which go to the far right-hand side of this page, and which come from all of our users, and we could pass them over the Unix domain socket, because there's a magic API for that, into the core here, and essentially do all of the processing of stuff for a document in that one process. That might help with some things, but it's not clear to me that that's a massive win. Otherwise, probably would have done it. Yeah, it's slightly uncomfortable having a tile cache, which is in the document broker. So we share tiles that have been rendered between multiple users, and we have a cache there, and then having another sort of delta cache in the kit process. Perhaps we could, I mean, they're in different formats and they're different sizes and so on, but it's possible that might make sense to unify at some point. I don't know. I'm sitting on the fence there. If some genius comes along and tells me why it's a good idea, we could do that. But I didn't think it's a huge performance issue. What else? So from another thing we should probably do is get more intelligent about this polling. So at the moment, I think the LibreOfficeKit gets fully idle before it lets us do anything useful. And so that means that an idle handler that is really not of a very high priority is taking priority over things that can be, like typing and rendering and stuff like that. So my take is that there's quite a chunk of latency improvement possible by just having a more intelligent API here for the Unipol thing. So I think that would really help. The same, shoot, yeah, do. If you've got something to say, great, jump in. Brilliant, go for it. It's supposed to be open.
Hello, can you hear me?
Yes, go for it. Yeah.
So one important thing here, and also in LibreOffice, is the response time, the delay that user actually experiences, and that affects the quality of user experience. So that there is a very well-known relation between the quality of user experience and that response time. Do you measure that response time, and is it possible to, let's say, use that with some kind of API, or let's say understand it while the online is in production to
Yes, it's a really good question. Thank you, Sven. So yes and yes. So Mevan has a good question around that on actually in the chat. So in recent times, I've written a thing called the Watchdog Timer, and so what the Watchdog does, and actually it's a really good slide to talk about that, is so at the beginning of the yield. I don't know if you can see my cursor. You can see my cursor. So at the beginning of the yield. In the LibreOfficeKit side, or actually this yield, what we do is we say, hey, we're going to sleep, right? So all is good. All is good with the world, nothing is going on. And when we come out of the yield, which means, pardon me, we're going back to event processing, we set a time. So we essentially put a timestamp as this loop goes round here. We put a timestamp that says we're no longer yielding. And what that allows us to do is to look at all those timestamps and say, how long has it been since we last got to go to sleep? You know, I'm feeling tired, Watchdog Timer. And as soon as I start to feel tired, which, you know, at the moment is like 100 milliseconds away from being responsive, processing events, then we start to send it signals. So we send it a sig user 2, I think. And maybe 2, maybe it's 1. Either way, we send it a signal, and inside the signal handler for that, which is very, very small, we call a random system call, where the random system call is, well, quite random. You know, like it's something that no one ever uses in a live Linux system. So the good thing about calling a random system call is that we can use the perf profiling infrastructure. So the perf profiling infrastructure then lets us see the stack trace of where we were when we were slow. If that makes sense? So any time that we take more than about 100 milliseconds of time, and we're not getting back to processing events, then we start to get samples of the code that's there. And that has been extremely interesting. Like, we've seen a whole load of things pop out of that you would just not expect. And the profile looks totally different to the CPU profile. So we have long-running CPU profiles on our servers that run, you know, for a whole week, and we profile every second, and we get a really good statistical picture of demo server users over that time. And we actually publish those on GitHub in a couple of trackers. Noel or someone could perhaps post a link to one of those trackers, so you can see where time is spent in an editing session. But when you look at the Watchdog profile, you see that this profile is nothing like the CPU time profile. It's just totally different. So that's because our work, I guess, is bursty. You know, we do something and it takes a long time, but the long time is small compared to the other things that go on, if that makes sense. Anyway, so the Watchdog has shown us some really interesting things. So for example, what are we doing? We were doing something with certificates, and that involves checking NSS something, which has a SQLite behind it. I think that's is that the Watchdog profiles there? Yeah, Miklos has got a link there for what's doing. But we also have some GitHub tickets with pictures in that you can just click on the link and see lots of nice flame graphs. And you know, this certificate thing that you would think was just not doing anything at all, actually turned out that it was loading a SQLite database, which was doing a whole lot of fsyncs, which was flushing lots of, you know, backed up disk changes, and none of that was needed at all, and it was causing, you know, a significant latency spike from just blocking the system, flushing the file system cache. So that was interesting. We see copy and paste, for example. We've seen some big copy and paste problems where it's been extremely slow, and I think actually Noel has fixed a number of surprisingly silly things in copy and paste that were just, you know, then blocking other users from using the app whilst the copy was running. Yeah, and various other things. I mean, we continue to look at that. If you see something there, do jump into it. And as time passes, we can shrink the latency we're willing to accept and get more data there. Annoyingly, the Watchdog timer tends to foul up the CPU usage because it turns out the Watchdog really, you know, consumes quite a lot of time continually waking up all night and seeing if anything's going on. So it tends to itself dominate the profile of the CPU time, but the Watchdog profile is very useful. Does that help, Hussein? That's one of the things we did quite recently, actually.
Yes, actually, that can be very helpful. But to add, I think something that can be used in production and visible in real-time production can be.
This can be used in production. It is you just set the setting, you run it, and it has a non-measurable impact on the on performance. Like, it's not going to slow your machine right down. And you can run perf, which is also quite efficient. So yeah, we run it on live systems. Obviously, our demo servers continually, and our share server we use internally. So yeah, it is that the Watchdog Timer is essentially that thing, I think.
Great, thanks.
Yeah. So do you have a poke? And if you find something interesting, we're interested to know. Cloth could probably set it up on your instance if you wanted to, and be useful. The more data we get, the better. Of course, there are other sources of latency, poor network connections and something, but I think they're increasingly rare. We send quite small packets of data to and fro by internet standards in these days, and so I suspect most of our latency is just doing stupid stuff, either in the browser or in the on the server. So back to Timur's question, in terms of performance, we got some more nice performance wins around. In the browser side, so Firefox particularly is not a happy browser when it comes to lots of JavaScript. So there's a big win landed there recently. But did that help, Timur? This all came out of your question, I guess, which is great. But
yeah, look, it depends on how you look. Like, you are speaking here about milliseconds and various gains, and then comes the document that takes like minutes to be open in LibreOffice.
Oh yes, so well, there you go.
The biggest bottleneck now.
There you go. So yes, I mean, I think there is always something that finds some horror algorithm to tickle that is going to take forever to load. Yes, and people optimize their documents for the competitor's Office suite, so they tend not to do things that make that horribly slow because they know that. So when we load them, we find where we need to optimize. But I'm optimistic that we're improving many things there. There's a lot of good stuff going in to improve stuff. Left and right, but yeah, I mean, it takes a long time to load. Is a relatively easy one. We currently have quite a nasty problem if you have like thousands of styles, where we try and thumbnail all of the styles and send them to the client before letting someone edit, which can lead to like a 10-second, 10-20-second load time and blank page and whatever, which is kind of awful. But Shimon, I think, is looking at that right now. But either way, this is more of a event queuing thing rather than a generic performance thing. So, any other questions, Timur? Or
oh, thanks.
Cool. I have a fellow Jitster and an Aaron and a Miklos and Noel and Hussein, and I think and a Torsten. And I think that I'm through everyone. Any questions or thoughts?
So one would be around when it comes to testing. Of course, testing async code is much more tricky compared to all boring synchronous code. And for these idles, we have this process to idles mechanism where we try to flush out all the pending jobs before we assert the state. So that seems to be the easier one. But do you have any thoughts on how to deal with timers? So for example, as you move around with your cursor, we have this nice timeout and not update, boldness and italic on the notebook bar and so on for half a second or something like that. And it's quite hard to reliably wait for that sign because it's not an idle, so you need to wait a bit, but like not too much and enough, and it seems to be a mess. So do you have any thoughts now?
Yeah. So one of the things that we've struggled with is, of course, exactly that. If you put a sleep in, then you can be reasonably sure that on an unloaded machine that the events have all happened, including these timeouts for a whole load of things, status bar, SFX bindings. So when you change the state of something, like if you move into a paragraph and it's bold, just by pressing arrow down in the cursor, typically you don't get a modification notification for your toolbars to make it look bold for another 250 milliseconds. Where 250 is an interesting number plucked out of the backside of whoever made this in the first instance. And this saves a whole lot of random processing as cursors jump around the document. But yeah, the downside is then that in order to wait, to make sure that's happened, it's not very easy to do it. As you say, Miklos, there is this idle handler thing that we can do that will force all of the idle and things to be handled. But of course that only happens in one process. So very typically we have a tester that pretends to be a browser, and it wants to send an event through and then be sure that all of the collateral damage from that event has happened, or all the processing coming out of it. And way back in the day, I wrote a thing that attempted to do this, which was like an instant sleep that would essentially jump your clock forward by, say, a second or 5 seconds, and would process the timeout early, and then all of the other things, and process all the events, and essentially get us down to a sort of ground zero of it's all happened in a single call. I think the vestiges of that are still there, and I think the API is still there in LibreOfficeKit to make that happen. But I don't know that I ever managed to articulate my idea well enough to get anyone to actually, fix and test this. And of course, yeah, with the browser, at least the Cypress tests by design don't really have good access to the WebSocket or any way of, well, they're not great at doing that. So maybe it was a solution without a problem or something. I don't know. But yes, it's a bit of a pain.
No, that's fair enough. It kind of answers the question.
Cool. Hussein, back again.
Yes. So it's more like a suggestion than a question, but I think it's important. For LibreOffice SDK, we have many examples for UNO API, which is ported to many languages thanks to some of the community members that I'm working with. So I think it would be nice to have some LibreOfficeKit examples in the core, and as myself, let's say I try to help by giving a patch that ships the LibreOfficeKit headers in the LibreOffice community builds, and and I think it would be nice if some of the people interested in LibreOfficeKit can help to add some examples in C++, Python, or some JavaScript examples there to generate more, let's say, awareness and things like that.
Yeah. So I think there's sort of two hearts I have here. So the first thing is the LibreOfficeKit API, almost all of it has a massive if-def, I really know what I'm doing, don't use this API unless you're totally clueful around it. And unless you define that, you don't really get most of the useful stuff, like, rendering to tiles, a whole lot of event processing and so on. And there's pretty much, there's a fairly good reason for that. I mean, so obviously it's still maturing. Secondly, it's sort of a data-based API, so we can change its behavior quite nicely without, being tied to ABI and API compatibility. So that's almost by design. Thirdly, I guess it's a Linux only, or maybe Linux and iOS and maybe Mac API. So we do DL opening and the various things that probably don't work terribly well on Windows. And fourthly, there are really currently only two major users of it, although I think some people use it for file conversion, which is one of the bits that isn't in the scary include guard. And we're quite happy about that. Like, it's really nice to talk to Michael and dung out some problem that we had with the JSON, we're generating the wrong JSON or whatever, and then know that there's only two people we need to talk to about it, which would be sort of the Android, the TDF Android version and Collabora Online. So obscurity has some benefits as well, Hussein. So I don't know that we want to encourage loads of people to do that. But there are some nice demo apps there. So there's a thing called Tile Bench that essentially benchmarks tile rendering. In the core, there's I think the GTK tile viewer, which is sometimes a good way to debug, tile rendering, and also something that looks like Collabora Online in one process. But yeah, I feel ambivalent about it. Does that make sense? Hopefully so.
Yeah. Thank you. I will try to do my best to add at least some more examples to make people excited about the capabilities of LibreOfficeKit, and let's see what happens.
Yeah. Absolutely. My worst nightmare, or one of my nightmares, would be that we're then tied to an API that we want to change. And to be fair, the LibreOfficeKit API is ripe for being ripped and replaced, I would say. It uses a sort of a bit of a Unix-like file descriptor type API and there's some benefits to that around, being able to validate various things, but also it's not the best thing in the world API-wise by a long way, and not terribly easy to understand which bits apply to documents and views, but anyway, it is what it is. Thanks, Hussein. Any other thoughts? Or otherwise, I have Noel and Torsten and Aaron and fellow Jitster on my list. I don't know if we still have a fellow Jitster. Oh, they may have left. Torsten, any thoughts? Comments? Wisdom? You're muted if you are speaking. We cannot hear you loud. Torsten? Now you're not muted, but we still can't. Well, at least I can't hear you. So,
just a comment from Noel.
Oh, you can hear Torsten, or
no? I was going to make another comment.
Oh, go for it. Yeah, go for it. Yeah.
While you've been talking, I've been running TSAN in the background on LibreOffice, just because I was a little bit bored today. Mm-hmm. And LibreOffice is absolutely chock-a-block full of data races. Just as an amusing aside.
Yes. That doesn't even slightly surprise me. I mean, we have a locking fetish, but I don't know that it actually makes things thread safe. I suspect there's a massive rat's nest of trying to fix those may well cause innumerable other problems, because yes. It's but we'll see. I mean, it sounds good. Not. I'm amused that we're. Back in the day, the config manager was one of the cause celebre, config manager 2, and it took 57 locks for every key read and released, and then it wasn't thread safe, which is quite exciting. A combination, of sort of overwork and incompetence, as it were. So. Yeah, I'm sure there's many similar things there, but good to have you on that, Noel. Great. Any other thoughts, Noel, or comments, or?
Nothing from me, no.
Cool. Richard, I don't know if you had any thoughts or questions.
It's interesting, but I'm trying. We'll see.
No problem. And I think that's about it. If there's anything else anyone wants to ask.
Okay, I see no questions more. Thank you, everyone, for participation. See you next week.
Well, we'll try and do this weekly, just a sort of bit of a rubric on that. I think we'll try and do this weekly. I think Torsten's team had some good ideas of things to talk about. Hussein, if you have some topics. We've been doing this internally for a long time, so there's a lot of content there. And hey, if we get enough people, we'll manage to write lots of conference slides before they actually have to be presented, which might be helpful for everyone. And I think it's just generally useful to try and train people in the code base and what's going on. So you're very welcome to join our initiative, and Anna is running it, as you can see. So if you have good ideas of things to talk about, do grab her. And if we have too much, we'll do it more regularly. But thanks, everyone. Happy hacking. Have a great week.
Everyone.
All the best.
See you next
Thank you.
Yes, thanks.
Bye.